Hello everyone, welcome to Pizzo Physics. I hope you people are doing well. In this particular video, we are going to start thermal expansion. So first of all, question arises, what is thermal expansion? As we know, the temperature of the body increases, then thermal vibration energy of molecules also increases. It means rate of collision between neighboring molecules also increases with the increase in temperature, right? Now, as collisions rate is increased, interatomic separation also will increase. That's why thermal expansion in the body will take place. So that's the particular process of thermal expansion. Generally, there are three types of different thermal expansion. One is linear expansion. Second is aerial expansion. Third is volumetric or cubical expansion. It is also known as cubical expansion, while aerial expansion is also known as superficial expansion. So that is our thermal expansion. Now let us look into what is linear expansion. So now let us discuss what is linear expansion. Consider one solid scale of length L at temperature T. Now, if temperature is increased by delta T, then this solid scale will expand by delta L. And now new length of the solid scale will be capital L plus delta L, right? So this increase in the length is a linear expansion. This expansion will directly proportional to the change in temperature delta T. Also, this change in length is directly proportional to original length L, right? Now, if we combine these both, we will have delta L is directly proportional to L into delta T. Now, if we want to remove this proportionality sign, then we have to put proportionality constant, that is alpha. That's why it will be alpha into L into delta T. Therefore, new length of the solid scale will be L plus delta L equals to L plus this much, that is alpha into L into delta T. If we put this new length as L final, then we will have L final equals to L into bracket में 1 plus alpha into delta T, right? So this is our new length L final, which is due to our linear expansion. Now here alpha is our linear expansion coefficient, which generally depends on the material of the body, right? So this is our linear expansion. Now let us discuss what will be the change in the radius if we increase the temperature, right? So consider initially we have ring of radius capital R. If its temperature is increased by delta T, so at new temperature T plus delta T, we will have new ring of radius R dash. Generally, this radius will be equal to R into 1 plus alpha into delta T. So that is R change in the radius with temperature. Now consider we have one semi ring in which we have 2 points like this. If the distance between this point initially is L, now if it is initially at temperature T, now we will increase its temperature by delta T. So this distance will increase with the temperature. If new length is L dash, that will be equals to L into 1 plus alpha into delta t. So this is our second special case. So we have to remember three formula. One is corresponding to length, which will be equal to L into 1 plus alpha into delta t, or else delta L equals to L into alpha into delta t. Second formula is of radius that equals to R into 1 plus alpha into delta t. We take change in radius that will be equals to R into alpha into delta t. So this is our main concept of linear expansion. Now let us solve some numericals so we can get better idea how to approach the problems. Our second problem is a metal rod A of 25 centimeter length expands by 0.05 centimeter when its temperature is raised from 0 degrees Celsius to 100 degrees Celsius. So LA equals to delta LA equals to LA into alpha A into delta T. So it is expanding by 0.05 centimeter. LA we do have 25. Alpha A we don't know. Delta T is 100. Right? So alpha A will be equals to 0.05 divided by 2500. Right? After solving this, we can get 5 into 10 power minus 2. And here we have 25 into 10 power 2. Right? So it is 5. And 1 by 5 will be 0.2 into this plus 2 power go upwards. So it will be 10 power minus 4. Right? Another rod B of different length 40 centimeter expands by 0.04 centimeter for the same rise in the temperature. So alpha directly we can write delta LB equals to LB into alpha B into delta T. So delta LB we do have 0.04 centimeter, LB we do have 14 centimeter, 40 centimeter, right? Alpha B we don't know, delta T is 100, right? So alpha B will be equals, directly I am writing it 10 power minus 5 degrees Celsius inverse, right? Now another third rod C of length 50 centimeter is made up of pieces of rods A and B placed end to end, expands by 0.03 centimeter, right? So take it as L1 plus L2 equals 50 centimeter, and new length L1 dash plus L2 dash we have 0.50.0 50.03 centimeter, right? So change in the length is 0.03 centimeter. So it will be corresponding to delta L1 plus delta L2. So here we can write alpha 1, that is alpha A, into L1 we don't know, into delta T, plus alpha B into L2 into delta T, right? Alpha A we do have 0.2 into 10 power minus 4. So it can be written as 10 power minus 5 into delta T, it is 50, right? Into L1 plus alpha B we have 10 power minus 5. L2 we do have, sorry, L2 we have to find, into delta T again we have 50. Here we have 3 into 10 power minus 2. So after solving it, 2L1 plus L2 will be equals to 3 into 10 power minus 2 divided by 50 into 10 power minus 5. So it will be 60 centimeter, right? So L1 plus L2 we do have 50 centimeter, and 2L1 plus L2 we do have 60 centimeter, right? So so 2L1 plus L2 we do have 60 centimeter, and by multiplying it with minus 1, so L1 minus L2 equals to minus 50 centimeter. So it will be L1 equals to 10 centimeter and L2 will be equals to 40 centimeter.